Chemical kinetics deals with the rate of reaction, while in thermodynamics we study the feasibility or spontaneity of the reaction. Chemical kinetics relates the rate of reaction with concentration of the reactants. It also tells you how the rate of reaction gets affected by change in concentration of reactants. But how do you define the rate of reaction? To define the rate of reaction, you can express the change in concentration with respect to time. So when you observe change of reactant concentration with respect to time, you will observe the concentration of reactant decreases with respect to time. But while you observe the concentration of product with respect to time, you will observe the product concentration increases with respect to time. Express the rate of reaction in terms of reactant, you will get decrease in concentration of reactant in a given period of time. So because there is decrease in concentration, so it will give you minus delta R over delta T. Here negative sign shows the decrease in concentration. It doesn't mean that the rate of reaction is negative in terms of reactants. Similarly, you can express the rate of reaction in terms of product as well. So you will get increase in concentration of product with respect to time, and you will get the formula plus delta P over delta T. Here you will get the positive sign that defines the increase in concentration of product. Rate of reaction can be of two types. It can be average or it can be instantaneous rate. Average rate is the rate of reaction measured over a period of time, while instantaneous rate is a rate of reaction measured at a specific instance. For example, when you observe the change in concentration of reactant with respect to time, you will get decrease in reactant concentration. But when you observe the rate of reaction at this particular instance, at this instance the rate of reaction will be the instantaneous rate. But when you observe the rate of reaction at this given period of time, so at this given period of time, rate of reaction will be the average rate of reaction. For the average rate of reaction, you will get the formula minus delta R over delta T. Similarly, for the instantaneous rate, you will get the formula minus dr over delta T. The only difference between average rate and instantaneous rate is that in average rate, we measured rate over a period of time, while the instantaneous rate is measured at a given instance. That's why in instantaneous rate we use D, while in average rate we use delta. Average rate can also be expressed in terms of product. In that case, you will get the formula delta P over delta T. Similarly, you can express the instantaneous rate in terms of product. So you will get the formula dP over delta T. Let's study the kinetics of the following equation. Here you can see 1 mole of nitrogen reacts with 3 moles of hydrogen, and it results in the formation of 2 moles of ammonia. So the average rate of disappearance of nitrogen can be given by minus delta N2 over delta T. Here you can observe only 1 mole of nitrogen is consumed in a given period of time. Similarly, when you observe the average rate of disappearance of hydrogen, here you can see 3 moles of hydrogen consumed in a given period of time. Now come to the rate of formation of ammonia. You will get the formula delta ammonia over delta T. Here you can see 2 moles of ammonia are formed in a given period of time. But as we just have studied, the rate of reaction either can be expressed in terms of change in concentration of reactants in a given period of time, or it can be expressed in terms of change in concentration of product in a given period of time. So that means the change in concentration of nitrogen or hydrogen or ammonia, they all are actually given the rate of reaction. But how is it possible to get the three different rate of reaction for a same reaction? So how do we overcome this problem of rate of reaction? This problem arises only because there are different number of reactants reacts and results different number of moles of product. To overcome such problem, rate of reaction can be expressed in terms of rate of consumption of reactants or the rate of formation of product divided by its coefficient in the balanced chemical equation. So let's write the rate of reaction that we have learned before. Average rate of reaction can be equal to minus change in concentration of nitrogen over delta T, or it can be written as change in concentration of hydrogen over delta T, or it can be equal to plus change in concentration of ammonia over delta T. So by the rule, you have to divide these change in concentration by their coefficients. In terms of nitrogen, nothing is written. That means there is 1. So here you have to divide change in concentration of nitrogen by its coefficient, that is 1. So here you will get the formula minus delta concentration of nitrogen over delta T. Now come to the hydrogen. In case of hydrogen, 3 is written. That means the coefficient of hydrogen is 3 in this balanced chemical equation. So you will get the average rate of reaction in terms of hydrogen as 1 by 3 delta change in concentration of hydrogen over delta T. Similarly, in case of ammonia, its coefficient is 2. So you have to divide this change in concentration of ammonia by 2. So you will get the formula average rate of reaction in terms of ammonia can be equal to 1 by 2 change in concentration of ammonia over delta T. Now let's check whether do we get the same rate of reaction in terms of each reactant and product. First check in terms of nitrogen. In case of nitrogen, 1 upon 1 multiplied by the change in concentration of nitrogen in a given period of time. So here we know only 1 mole of nitrogen is consumed in a given period of time. Similarly, in case of hydrogen, first write minus 1 by 3. How many moles of hydrogen get consumed in a given period of time? There are 3 moles of hydrogen consumed in a given period of time. Now come to the ammonia. First write 1 by 2. How many moles of ammonia are formed? So there are 2 moles of ammonia are formed in a given period of time. Now calculate each of them. So when you calculate it, 3 get cancelled with 3, 2 get cancelled with 2. So here in each case you will get the rate of reaction as 1 upon T. So here now we get the same rate of reaction in terms of each reactant and product. Similarly, you will get the instantaneous rate of reaction by dividing the rate of consumption of reactant or the formation of product by its coefficient in a balanced chemical equation. So the instantaneous rate of reaction can be equal to minus d N2 over delta T or minus 1 by 3 d H2 over delta T, or it can be equal to plus 1 by 2 d NH3 over delta T. Here 1, 3 and 2, these are the coefficients in the balanced chemical equation. So let's check what you have learned in this video. For a reaction, 2N2O5 gives 4NO2 plus O2. At a particular moment during the reaction, N2O5 disappeared at the rate of 0.02 molar per second. At what rates NO2 and O2 are formed? And what is the rate of reaction? So first write what is given in the equation. In the equation, rate of disappearance of N2O5 is given, that is equal to 0.02 molar per second. That means minus d N2O5 over dt is given. And what is asked to calculate? You have to calculate the rate of formation of NO2 and O2. That means dNO2 over dt and dO2 over dt, and the rate of reaction you have to calculate. Instantaneous rate of disappearance of N2O5 is given in the question, that is 0.02 molar per second. For the given equation, you can write the rate of reaction as 1 by 2 d N2O5 over dt, or it can be equal to plus 1 by 4 dNO2 upon dt, or it can be equal to dO2 over dt. Here 2 is the coefficient of N2O5. Here 4 is the coefficient of NO2. And in front of O2, nothing is written. That means there is 1. So from the rate of reaction, you can get this relation. So write down the relation. 1 by 2 d N2O5 over dt is equal to 1 by 4 d NO2 upon dt. You don't have to write the negative sign here because it only expresses the decrease in concentration. Now transfer 1 by 4 on the left side of the equation. So you will get 4 by 2 dN2O5 over dt is equal to dNO2 over dt. Now place the value of dN2O5 over dt that is given in the equation. So you will get 2 multiplied by 0.02 molar per second is equal to d NO2 over dt. When you solve it, you will get 0.04 molar per second. So we just have calculated the rate of formation of NO2. Now come to the rate of formation of O. For that, you can get the relation from the rate of reaction, that is 1 by 2 d N2O5 over dt is equal to dO2 over dt. Now write down this relationship. Half dN2O5 over dt is equal to dO2 over dt. Now place the value of disappearance of N2O5 over dt that is given in the question. So when you divide this term, you will get 0.01. So the formation of O2 will be equal to 0.01 molar per second. And from the equation, you can see the rate of reaction is also equal to the rate of formation of oxygen. That means the rate of reaction is also equal to the formation rate of oxygen, that is 0.01 molar per second. I hope now you understand what is the rate of reaction and what is average and instantaneous rate of reaction. In the next video, we are going to discuss rate laws.